I built a whole robot just so I could capture the same image repeatedly. Is it overkill? Absolutely. Is it solving a real problem? Well, yeah, actually it is. For my second channel, Mandic Labs, I have a project where I need close-up, high-detail images of 15 3D printer hot ends. So in comes my macro photography setup. This is a not insignificant chunk of camera gear to get high-detail close-up pictures. But for how expensive this is, it still doesn't get quite as close or high detail as I would like, and I want 2 angles for the project I'm working on. So in comes this benchtop digital microscope. When it comes to electronics projects, soldering, getting a magnified view of what you're working on, this thing is great. What I'm trying to do with it, not so much. I can line up one of my 3D printer nozzles under it, and when I adjust the focus, it jumps all over the place. And don't even get me started on actually adjusting the position to get that nozzle lined up again, because it's just not a fine adjustment system. I believe I can make this scope do what I need, but the base and everything else around it has to change. So it's a darn good thing that, as my partner Ruby would say, I am a magpie. I have electronics, linear rails, motors. I think everything I need to build something better is already here in stock. For anything I don't have, there's always this video's sponsor, PCBWay. You can check out their website and see the wide range of services they have on offer and get quick, easy quotes on them, whether it be CNC machining, laser cutting, 3D printing, including 3D printing metal, or as their name implies, PCB manufacturing and assembly services. PCBWay can take care of your needs quick and easy, whether it be a small business manufacturing run to a one-off hobbyist project, they've got you covered. Check them out at the link in the description. Thank you to them for supporting Mandic Labs 2.0. Let's get into building this overkill project and see how PCBWay is going to help. Magpie, Pack Rat, Hoarder. I get that my desire to hold on to things that I see future potential in can easily tip the madness scales into a problem. But then I have a project like this where having what I need on hand saves me time, money, energy. I can design with constraints because I've got parts right here that I can work from. Old 3D printers that I tore down and saved the individual components of can become useful again. Not working from a kit does mean having to modify things, having to make them make sense for my project. I have to cut my extrusions down. I have to drill and tap them. Luckily, I had a pair of MGN9 linear rails for the Z-axis that are going to be great for this application and make a nice rigid setup. But when it comes to the X-axis, the linear rail I had was a little too long. It was off one of my previous Voron projects, and I need to cut it down to length. You can do this, but you're going to need a quality fiber disc, aka cutoff wheel, to do it. If you could cut a linear rail with a hacksaw, it's not a good quality linear rail. The basic premise of this project is a more rigid support structure for that microscope, so I have to consider that when it comes to my 3D printed components. As such, I'm going to use this carbon fiber reinforced ASA material from Ambrosia by West 3D. The carbon fiber reinforcement will make the part more rigid, as well as giving it that beautiful carbon fiber printed texture on it, and I think the purple matches my branding loosely, but well. This part in particular is the heart of our motion system. It's going to tie together the up and down to the in and out movement, so we need it to be rock solid. That's why I'm installing it to not 1, but 2 linear rails, which are mounted perpendicular to each other. This will provide not only up and down support, but also side to side motion control, and should make all of this just more stable and rigid. I can't overstate how much that is the focus of this project, which is why we really need to get this mounted onto a base. For that base, my Magpie brain told me I had the perfect solution. A few weeks ago, one of my neighbors at the studio moved out. When they did, I went dumpster diving. I surfaced with this black gold, acrylic that I felt was meant to be. It wasn't. Real talk, it's been in the bed of my truck for weeks at this point. I quickly realized it was not going to work. It's extruded acrylic, not cast. It's too large to fit into my laser cutter, so I would have to cut it, plus these wings on it. It just didn't make sense, so I ordered fresh material to do this project. However much I want this to be a pure pack rat build, this choice has taken me back to a lesson I know I've already learned. In my metal fabrication days, customers or even bosses would bring me scrap metal, hoping I'd build a project out of it. And most of the time, I would say no. The time to strip rust or grind off old brackets just to reach a clean starting point ate up whatever they thought they were saving. It simply wasn't worth it. Unfortunately, it's the same with my dumpster acrylic. It'd be nice for a story aspect, but starting fresh is a smarter call. Even on hobby projects, time is a finite resource we can't make more of. So if you don't have a laser of your own, that's where this video sponsor PCBWay can save you some time. Send them files and they can cut you parts like these, quick and easy. That gets you back to the fun part of your build a lot faster. Mine starts with the whole reason I'm making the base out of acrylic and not metal. I want it to glow with RGB. This is 2 pieces of black acrylic that's sandwiched 2 of clear in between. The clear ones have a handful of channels cut into them, allowing LED strips to be installed. The outer channels have RGB facing out, so the perimeter of the base will glow colorful. The inner channel gets white LEDs that face inward so they can shine up through the top panel of the base and backlight whatever subject I'm looking at. Of course, that's only the top half of the base. The LEDs and the rest of the hardware need somewhere for their brains to live. So in come these printed skirts that are going to make up the perimeter of an electronics box under the acrylic. This is the always a little slow, fiddly gremlin work that sneaks into every one of my builds. With the box assembled, it's time to get the robot brains installed. This is the board that's going to control the motion system in this machine. It's an old main board out of an Ender 3 3D printer. I tore it down for parts years ago, and finally, it's going to serve a purpose other than taking up drawer space. I'm also going to use the encoder screen off of that same Ender 3, so I have control interface on the machine. To be able to control the RGB the way that I want, I'm using my favorite WLED controller board, Y'all. This was made for me by this video sponsor, PCBWay, and it handles the WLED firmware that I use to control the RGB throughout my studio and allow me to sync up the colors and effects I want across multiple setups. A barrel jack goes into the back skirt, and a 24-volt power brick will supply power to the entire thing through just one cable. This USB-C port will allow me to send 5-volt power out to the microscope itself so that it won't require a separate power supply. And to cap off the box, there's nothing. I didn't bother to make a bottom plate for it, just because I'm the only one who's going to be moving it around. It's unlikely to be plugged in when I do, and absolute worst case, if it is, I rudely meet 24 volts. I've had worse. With the brains boxed, it's time to cap off the base with its top panel. I laser cut a couple of vaguely cyberpunk details into the top plate and putting some clear acrylic pieces superglued in to those. The first one squeezed out superglue. I panicked, wiped it up too quickly, and smeared it all over the top acrylic. It's going to remain as a monument to my overreaction. With the base bullseyed, it's time to build our way up with the Z-axis. Installing this really requires 3 hands. I don't have a third, so I'm going to have to settle for my double chin instead. With that installed, we can stand it back up on its own 4 feet and be thankful that I forgot to take the rubber stoppers out because the Z-axis almost fell and smashed onto the acrylic. To motivate our movement, we're going to use an Ender 3 Z-axis motor. You can kind of see how this had to happen in stages. The motor installs from underneath up through the acrylic base plate that then threads into the moving print component, screws passed down through the printed parts and acrylic base plate into the motor to hold it all together. There's a lot of this has to happen, then that. But we have movement. Hoisting hardware hung, it's time for our side-to-side motion. The core of this is an adapter carriage plate that mounts to the linear rail and has a dovetail receiver on it. This is so I can then slide a mount for the microscope into this dovetail. So in the future, if I go to a different microscope, a different camera setup, I can just redesign one mount and use all the rest of the same components, simplifying and future-proofing. Less simple is the lead screw for the X-axis. It's far too long, so it needs a haircut. Mounting our X motor assembly is all pretty much rinse and repeat from the Z-axis. And last but most certainly not least, you can see how the microscope's dovetail mount works. The base lighting from earlier is good, but what you're looking at needs illumination too. So this under extrusion LED light bar will shine light across the top of the plate so that everything should get some additional lighting. That said, there's a trick. When you get a camera really close to whatever you're looking at, it can block lighting itself. Everything I've got, my studio lights, even that bar we just mounted, it could all be blocked when the lens gets too close. So this LED ring light has a strip running 360 around the lens right where the lens is going to be so that it will illuminate what you're looking at up close and personal. Of course, before we can light it up or move anything, it's got to get wired. I'm not going to bore you with a step-by-step of wiring this up. I am sleeving it with teal and purple, my brand colors, sleeving so that it matches my aesthetic and really finishes off this build, which, seeing it come together like this really highlights. I built this from parts I had. A pile of old printer parts that I refused to throw away. Board, screen, motors, even linear rails off of old builds. It's stuff that's been taking up more space than I probably should dedicate to it for a while, but it's finally bolted into one machine that's actually going to do something for me. Well, it'll do something once it works. This motor on the X-axis is dead. The challenges of using parts that have been kicking around in a toolbox for years, you've moved across the country with them, sometimes this is going to happen. Luckily, I have even more motors. With that motor swapped, our wiring is complete. That's assembly. Now we just need to test to see if it works the way we intend. Should be lights. All right. Time to test if it moves. Let's go ahead and move X. All right. Move on Z. That's it. There's X and Z on the system. With both of those confirmed working, I'm going to give it a bit of a shakedown run, move it through its full range of motion, and see what it can do. It's not a fast system, but I'm trying to just reposition a camera here, so it doesn't need to be. Silly dance moves done, let me show you what I'm actually intending to use this for. Like I said at the start of this project, this whole thing is about taking the same picture over and over. I'm trying to show the wear on the tip of a 3D printer nozzle, which is a pretty tiny thing. So to get a high detail image of that, I need to take a bunch of photos of it so I can stack them together in software. This is stepping the camera away from the nozzle a fraction of a millimeter at a time, taking a picture at each step, which can be stacked together into one sharp image. That means all the effort we just went through, designing, printing, cutting, putting this assembly together, was for a grand total of 0.44 millimeter of travel. This thing has like 270 millimeters of total Z travel, and I'm using less than 1. Realistically, I could have done this in a simpler method by hand, but I have to do it repeatedly on a bunch of different hot ends before and after wear testing, and having a robot that can just run the same code over and over to repeat the process is going to make better results, better data, and my life easier. Now that this setup is rigid, that means that those 22 photos I'm taking, I don't have to worry about them moving side to side, creating a blurry image and ruining the whole result. I can rely on this now. That said, you might have noticed that those pictures I took aren't the prettiest things. That has nothing to do with the robot. It's all down to this glorified webcam of a microscope. That's why I'm happy I made this a modular system. I'll be able to ditch this scope and put whatever camera sensor I want on here. I'm leaning toward a grayscale machine vision sensor. If you have a recommendation, let me know in the comments. I'd love to hear it. There is one other upgrade I can already see I'm probably going to want to make, and it's to this acrylic base. Don't get me wrong, it looks great, and it's already way better than the mount we replaced, but it isn't quite as rigid as I'd hoped. Just resting my hands on it when I'm trying to adjust things, you can actually see the camera shift a little bit. You do have to remember this is very magnified, so that's really only a minor movement, but it's moving. Importantly though, when I take my hands off, it returns back to where it was aimed. There's no harm done. Down the road, I see swapping this out for a metal one, something PCBWay could cut quick for a project like this. For now, the setup works as it is, so I'm gonna roll with it. Standing back and looking at this project, I can honestly say that almost every part of this came out of my parts bins and material stock. The only things that I bought for this project were the acrylic for the base plate and the specific purple filament I used for the 3D prints because I wanted that color. Every other piece of this came out of the madness that is my studio and my mind. Ruby may have a point about my magpie nature, but this time it paid off. We built a whole microscope, motion, inspection station system using spare parts I had lying around. That definitely justifies the piles of spare parts, right? Hope you found this one interesting, folks. If you did, drop it a like, let me know in the comments. What camera would you put on this setup? Have you built anything fun with some old 3D printer parts? Love to hear about it. Be sure to get subscribed to ensure your 3D prints don't fail. It's not a guarantee, but it can't hurt. See ya.